COMSOL Multiphysics Lecture 11 Flow Analysis Part 2 Mixing of Hot and Cold Water. First of all, make sure that the software is loaded and also the live link is checked, and enter COMSOL environment. We'll choose two different procedures, laminar flow and heat transfer in fluid. So we open a 3D model and choose first a laminar flow procedure, and also load the heat transfer of fluid, and we load both procedures and define it as a stationary procedure. And now we're inside the COMSOL environment. The first step is to load the geometry from CAE system. So we have finished with the first step, geometry. The second step would be material. Right-click the mouse and choose water from material library. And make sure that geometry is connected or linked with the material property. Step 3, meshing. I'll give it a coarser mesh because in practice we always want to save time. So I'll choose coarser mesh for practice. And for step 4, we have two things to define. First of all, we need to define inlet and outlet flow. For the inlet, the water comes in from both surfaces with a mass flow rate of 0.005 or 5 cc or 5 millimeters per second from both surfaces. So this is the inlet flow property. And outlet flow property would be a pressure outlet at the bottom, and the 0 means it is atmosphere pressure or ambient pressure, the pressure of atmosphere. And this is the boundary conditions, inlet, outlet, for laminar flow. And for heat transfer, we also need to define boundary conditions. For temperatures, the temperature of the left surface will be 90 degrees, 90 plus 273. So this is 90 degrees C or 363 degree K. And also we need to define another temperature inlet here at the right surface. It will be 20 degrees C. And since this procedure has already defined all the surfaces to be an insulating surface, so I have to redefine the bottom surface. So I choose the open boundary selection for the bottom surface to override the insulation option. So I have defined the temperature at the left boundary, at the right boundary, and open boundary solution at the bottom boundary. And now since the procedure is for static analysis, so I don't have to define time steps. So I'll simply click compute to solve the procedure. And the result will have pressure distributions, velocity distributions, and also temperature distributions. And what I need is primarily temperature distribution of the flow. So I'll look at the temperature distribution of the load. And this is the temperature distribution. And for the surface plot, the color is a thermal light scheme. I'll change into rainbow light scheme. So I like this color scheme better because normally we'll look at hot area as red color and cold area with blue color, and warm color for a yellow color, a green color for the warm water part. And we also have a velocity distribution and pressure distribution of the plot. And we can also change the color scheme into fillet, for example, or you play with other solution or other color schemes. So this is for COMSOL Multiphysics Lecture 11, the flow simulation part 2 for mixing of hot water and cold water.